Good day everyone, especially to our viewers in our official Facebook page and listeners in 98.3 Gold FM. Welcome once again here at Salida TeleRadyo in La Filipina National High School. I am your teacher host, Teacher Jessa A. Banico. Today, we will learn another terrific topic in Science 7, Quarter 3, Module 3, as our teacher broadcaster, Teacher Ruby Jane A. Planas, will discuss about sound. Are you now all ready? That's great! I will now turn you over to Teacher Ruby.
Good day, viewers and listeners. I'm Teacher Ruby, your teacher broadcaster for this day. Welcome to another scientific learning journey in Science 7 with the topic sound of Module 3, Quarter 3 of the Self-Learning Module. The learning competency is to describe the characteristics of sound using the concepts of wavelength, velocity, and amplitude. The learning objectives are: first, determine how sound travels in different media. Second, describe the characteristics of sound. Third, identify the different ranges of wavelengths in sound. Can you imagine this world without sound? We would have not enjoyed the chirping of birds, the wind blowing in trees, the roaring of a lion, and the melody of music. Before we begin, let us test ourselves on what we know about sound. The following statements will test your prior knowledge about sound. Kindly get your pen and any sheet of paper to write your answer. I want you to answer it honestly. Write agree if the statement is correct and disagree if it is wrong. I will just read the statement twice and then after 3 seconds, I will give the correct answer. Okay, students? Let's start! Number 1. Sound is produced when matter vibrates. Sound is produced when matter vibrates. Your time starts now. The answer is agree. Sound is a form of energy and it comes from vibrations. It is produced by vibrating objects. Anything that vibrates produces sound. In human beings, the vibration of the vocal cords produces sound. It is when you speak, your vocal cords vibrate. Particles of air simply move back and forth. Number 2. As an object vibrates, it gives energy to the particles of matter around it. As an object vibrates, it gives energy to the particles of matter around it. Your time starts now. The answer is agree. When an object vibrates, it exerts a force on the surrounding air. Number 3. Sound is a transverse wave. Sound is a transverse wave. Your time starts now. The answer is disagree. Sound is an example of longitudinal wave. It is also classified as mechanical wave. Thus, it requires a matter or medium for which sound should travel and propagate. Number 4. Sound wave moves with a series of compressions and rarefactions. Sound wave moves with a series of compressions and rarefactions. Your time starts now. The answer is agree. In sound waves, vibrations of the medium create a series of compression and rarefaction which result to longitudinal wave. Compressions are the close together part of a wave, while rarefactions are the spread out part of a wave. Number 5. Sound can travel in a vacuum. Sound can travel in a vacuum. Your time starts now. The answer is disagree. Vacuum is an empty space which there is no air or other gas. In spaces where there was just vacuum and no matter, sound will not travel because there won't be any molecules to vibrate. An example is a radio. A radio would not work in outer space because there's no any medium for sound to travel through. But how sound travels in different media? In which media does sound travel fastest? Sound requires a medium to propagate. Medium is what the wave travels through, such as solid, liquid, and gases. No medium means no sound. Sound waves travel fastest in matter that is closely packed like solid, slowest in matter that is loosely packed like gas. In liquid, matter is not tightly packed. But why does sound travel faster in a solid than in a gas or liquid? It is because the closer the molecules are together, the faster they can collide and transfer energy. Okay, students, how's your scores? Did you get all the answers correctly? Great! Now that we already know about sound and the different media in which sound travels and propagates, let us now move on to the characteristics of sound. Let's have first the guide question. How frequency and pitch related? How intensity and loudness related? Let's first answer how frequency and pitch related. Pitch refers to the highness or lowness of sound. Frequency is the number of times the wavelength occurs in 1 second. Frequency has a unit of 1/second or hertz. The faster the sound vibrates, the higher the frequency. It means the higher the frequency of vibration, the higher is the pitch. Pitch depends on how fast the particles of the medium vibrate. Pitch is the number of waves in a given amount of time, also known as frequency, meaning the pitch depends on the frequency. A sound wave with a lower frequency and longer wavelength is perceived to have a lower pitch. A sound wave with a higher frequency and a shorter wavelength is perceived to have a higher pitch. Frequency determines pitch. It is dependent on the frequency of the sound wave. The higher the frequency, the higher the sound produced. Wavelength and frequency are inversely proportional. Higher pitch has higher frequency and has smaller wavelength. Lower pitch has less frequency and has a bigger wavelength. Now, how amplitude and loudness related? The strength or power of a wave signal is an amplitude. Higher amplitude are interpreted as a higher volume. Meaning to say, the larger the amplitude of vibration, the louder is the sound. Hence the name amplifier for a device which increases amplitude. Loudness refers to how loud or soft a sound is perceived to be. Loudness of sound depends on its amplitude. A sound wave with a higher amplitude and energy is perceived as a louder sound. A sound wave with a lower amplitude and energy is perceived as a softer sound. Amplitude determines loudness. The greater the amplitude, the louder the sound produced. To all listeners and viewers, this is the decibel range chart. Decibel is the unit for volume. It was named after Alexander Graham Bell, who invented the telephone. It is from the threshold of human being of 0 decibel to human pain threshold of 130 decibel. Breathing has 10 decibel. Whisper, light snoring has 20 decibel. Quiet room has 30 decibel. Moderate snoring has 40 decibel. Average office noise, conversation, has 50 decibel. Busy street, alarm clock, has 60 decibel. Hair dryer, noisy restaurant has 70 decibel. A loud radio has 80 decibel. Bass drum has 90 decibel. Subway train has 100 decibel. Industrial noise has 110 decibel, while jet plane takeoff has 120 decibel. Now, let us have an activity. Guess the sound. There are different sources of sound, like a musical instrument, sound coming from animals, and other sound that we hear around us every day. In this activity, I will play an audio clip coming from different sources of sound. And all you have to do is to listen. Students, get again your pen and paper to write your answer. This time, you are going to identify the following: sound as high pitch or low pitch, and loud or soft sound. And please answer it honestly. So let's begin. Listen carefully to the sound from a trumpet, which is a brass instrument. A. High-pitched sound, or B. Low-pitched sound. Again. Is it A. High-pitched sound, or B. Low-pitched sound? For the next sound, listen carefully to the sound coming from a tuba, which is also a brass instrument. Is it a high-pitched sound or a low-pitched sound? Again. Is it A. high-pitched sound or low-pitched sound? The answer is letter B. It is a low-pitched sound. The third sound is coming from a school bell. Listen carefully. Is it a loud sound or a soft sound? Again. Is it A. loud sound or B. soft sound? The answer is letter A. It is a loud sound. And the last one is a sound coming from a chirping bird. Is it A. loud sound or B. soft sound? Again. Is it a loud sound or soft sound? The answer is letter B. It is a soft sound. Students, did you get all the answers correctly? Good job! Now let's proceed with the different ranges of wavelengths in sound. In infrasound, sounds with frequencies below the normal range of hearing. Extremely low frequencies below 20 Hz, which means it cannot be heard by the human ear but can cause damage. Infrasound is very useful as it travels very long distances and can be used as a method of communication between animals and a way of detecting earthquakes and volcanoes because it produces infrasonic sound. Elephants are also capable of using infrasound. They can hear waves as low as 14 Hz. They use it to communicate between herds and to warn about predators in the area. Their lower sound and longer wavelength allow the message to travel for several miles. Audible sound, or human hearing range. Range of sound frequencies between 20 to 20,000 Hz. It is a kind of sound wave which human ear can hear. The third one is ultrasound. Has a vibrational frequencies higher than 20,000 Hz, which is above the normal human range of hearing. It cannot be detected by human ear, but some animals do. Also uses in ultrasound. Dogs can detect as high as 50,000 Hz. Cats can hear up to 64,000 Hz. Bats can hear up to 100,000 Hz and sometimes pick up noises as high as 200,000 Hz. Dolphins hear tones with a frequency up to 160 Hz. This means dolphins can hear 7 times better than humans do. Seeing with sound. We can see images of your baby brother or sister when the OB/GYN asks your mother to undergo ultrasound imaging. Ultrasonic waves are above 20,000 Hz are used to help physicians see our internal organs. Students, I want you to get again your pen and paper to write your answer. Let's check your understanding by answering the following questions. Answer it honestly. I will just read the question twice, and then after 3 seconds, I will give the correct answer. Okay, students? Let's begin. Number 1. A range of sound frequencies between 20 and 20,000 Hz. A. Audible sound. B. Ultrasound. A range of sound frequencies between 20 and 20,000 Hz. A. Audible sound. B. Ultrasound. Your 3 seconds starts now. The answer is letter A, audible sound. Number 2. A vibrational frequencies higher than 20,000 Hz, which is above the normal human range of hearing. A. Ultrasound. B. Infrasound. A vibrational frequencies higher than 20,000 Hz, which is above the normal human hearing range. A. Ultrasound. B. Infrasound. Your 3 seconds starts now. The answer is letter A, ultrasound. Number 3. An extremely low frequencies below 20 Hz. A. Ultrasound. B. Infrasound. An extremely low frequencies below 20 Hz. A. Ultrasound. B. Infrasound. Your 3 seconds starts now. The answer is letter B, infrasound. I hope that you were able to answer the given questions correctly. Keep it up, students! Good job! For your assignment, you can write your answer on any sheet of paper and submit it to your Science 7 teachers. I want you to explain why you hear a sound when you clap your hands together. You can also post in social media about what you have learned in our lesson. That ends our lesson for this day. But before we will end our lesson, I would like to leave a quote from Rumi. Listen to the sound of faith within you. Thank you for watching and listening. Keep safe, everyone. Bye!
Amazing! Thank you so much for that terrific discussion, Teacher Ruby. And also, thank you so much to our viewers and listeners for tuning in. I hope that you have learned another terrific learning for this day. Again, this is Teacher Jessa A. Banico, your teacher host, saying, do all for the glory of God, to God be the glory.